Greetings, Mr. Color's class. We're going to get into section 12.4, phase changes for kinetic molecular theory. And our idea is that we're going to be moving through these different phases, focusing on that phase diagram and how either the addition or removal of energy can cause that phase change. So one of our key things that we have is this graph here that's showing a couple key things. What I want you to include and write down now is this important information at the top of the page. So this is our key information for this section. Temp does not change during a phase change. Explanation point, red highlighted, everything like that, so that we remember that information as we're going forward. When changing the state of matter, adding energy does not change the temperature. Instead, it is breaking or forming those intermolecular forces during this period. So when we look at this graph, as heat is added, so an example is you're just on a hot plate. So you're just adding heat, adding heat, adding heat. Notice that as you add heat, so you're going as you're along the solid, you're increasing temperature. So your temperature is going up. But once you get to the state change, freezing and melting, going from a solid to a liquid, that energy that's being applied goes to making and breaking those intermolecular forces. So instead of increasing temperature, it's going to others. Now, once you get all of the solid gone and we're all liquid, that temperature then rises up during that time as we keep adding heat. But once we get all of that liquid to start to turn to a gas, as it turns to a gas, all of that energy instead is going to turn that liquid into a gas. And then to get it all to a gas, then we can increase that temperature again. So during our phase changes, forming or breaking those intermolecular forces, we don't have a phase or we don't have a temperature change occurring. All that energy is going to making and breaking those IMFs. So going from a liquid to a solid or solid to a liquid, freezing or melting, and then liquid to a gas, gas to a liquid, energy is going to that instead of changing temperature. So there are 6 phase changes we need to know. We are very familiar with these phase changes. So our phase changes, going from a solid to liquid to gas, as we're working, melting and freezing are very common terms that we know about, going from a solid going to a liquid or liquid to a solid. Condensation and vaporization is going gas to liquid or liquid to gas. And then our tricky one here that we might need to spend just a little bit extra info on is the idea of sublimation and deposition. These two are the more unusual ones, going from a gas to a solid or solid to a gas right away. We'll see an example with that with dry ice coming up as it goes right from a solid to a gas. And so that's where it gets its name from. So our first ones to know, endothermic. When we think about this, think about it from the particles perspective. So think about it from the molecule side of things. So endothermic, heat entering. Thermic is heat. Endo is to go in or to enter. So heat is going in to the molecule. So when we think about that, if we were to start out as a solid, to go to a liquid, heat would be needing or energy would be needing to go in. Liquid to a gas, heat would be needing to enter. Remember, heat is going to cause motion. And as the particles are moving faster and faster, eventually heat can actually be used also to go from our solid to our gas. So that would be our third one for us to look into. Vaporization, liquid to a gas like boiling, sublimation, solid to gas, or solid to liquid are 3 heat entering. The opposite version, exothermic. Exothermic is going to be heat exiting, so it's going to leave the molecule. For that to happen, if we wanted to go from a liquid to a solid, we would release energy. in order to form those intermolecular forces, causing it to go from a liquid to a solid, or a gas to a liquid, or even a gas to a solid to make dry ice. So deposition would be making of dry ice, freezing, condensation, all of those are releasing energy in order to make those. Endothermic is heat going in, exothermic is heat being released. So those 6 phase changes we need to have you know about. Vaporization versus evaporation, both of these are liquid to gas. Vaporization is above or at the boiling point. So we know that when we think about air pressure pushing down versus when we heat something up, if we're below the boiling point, 7 degrees Celsius, we're still going to get some water that leaves, but a lot more stays in the container because of air pressure pushing down. If we are above or at boiling point, we actually get a lot more, 100 degrees Celsius, we get a lot more to evaporate. That pressure that's pushing down isn't as great as that liquid wanting to escape, and we can see those bubbles start to form at the bottom and move their way to the top and actually escape out the top. Still get some escape, just not as much in comparison. Evaporation only occurs at the surface of the liquid at lower temperature than the boiling point. So underneath the temperature of the boiling point or lower. So things still will go from a liquid to a gas even below that boiling point. Boiling points, vapor pressure, the last part of there, needing that pressure to actually break or to actually get free of the atmospheric pressure pushing down on the gas or liquid in order for it to get to a gas. Boiling point, temperature, which is the vapor pressure of the liquid equals the external pressure from the atmosphere. So as we're working, the liquid trying to get to a gas versus that pressure pushing down. Once we get to that boiling point, it allows that liquid to escape as a gas. So key part is our phase changes for this section. Hey, safe travels to everyone.